Let's begin with the fundamental property of rational expressions. Let A, B, and C be variable quantities, with B not equal to 0 and C not equal to 0. Then, if you have the product of A times C divided by the product of B times C, this is equivalent to A over B. That's because C divided by C is simply 1. To state again, the fundamental property of rational expressions states that if the numerator and denominator of a rational expression share a factor, then the rational expression may be reduced by eliminating that common factor. The key word here is factor. In other words, in order to cancel things, we must have products in the numerator and the denominator. Let me explain. Take a look at the following example, x squared minus 1 over x squared plus 4x plus 3. Now, we might be tempted, in fact, most people are tempted right away to say, look, I want to reduce this, simplify this rational expression. And they might be tempted to right away cancel the x squareds. But notice, these are not products on the top, and this is not a product on the bottom. The x squared is connected to the 1 by a minus sign. That makes x squared and 1 terms, not factors. And on the bottom, the x squared is connected by a plus sign to the 4x and a plus sign to the 3. These are terms, not factors. Factors are things that are multiplied together. So, if we want to reduce this rational expression, the first thing we have to do is factor the top and factor the bottom, and then see if there's any common factors that can be canceled. Our top can be factored using difference of squares. That gives us x plus 1 times x minus 1. And our bottom, our denominator, can be factored as x plus 1 times x plus 3. Now observe, we have a product, 2 factors in the numerator, and a product, 2 factors in the denominator. And we can now apply the fundamental theorem, or the fundamental property of rational expressions. We can cancel the common factor of x plus 1, because x plus 1 divided by x plus 1 is 1, and 1 times x minus 1 is x minus 1. 1 times x plus 3 is x plus 3. This means that our rational expression x squared minus 1 over x squared plus 4x plus 3 reduces to simply the rational expression x minus 1 over x plus 3. Let me remind you that this is our final answer, x minus 1 over x plus 3. You may be tempted to reduce farther and cancel the x's, but notice x is not getting multiplied by the 1. They're being subtracted. These are terms, not factors. Similarly, the x is not getting multiplied by the 3. It's being added. These are terms, not factors. You cannot cancel these x's. So your final answer is simply x minus 1 over x plus 3. Let me add another remark. Writing the 1 when you reduce your common factors is very important, especially when there's only a single factor in the numerator. Let me explain. Let's consider the rational expression x divided by x times 2x plus 5. Now notice here we have a product in the denominator. That means that we can cancel this common factor of x from the numerator and the denominator. When we cancel that common factor of x, notice we're left with 1 divided by 1 because x divided by x is 1. You have to be careful. You must keep that 1 in the numerator. Now some students will forget to put that 1 in the numerator, and that's bad because 1 holds the place of the numerator. 1 divided by 2x plus 5 is not equivalent to 2x plus 5. They're not the same thing. So please remember to always put your 1. Let's recap what's been stated thus far. We're talking about simplifying rational expressions. That is, we're trying to put our rational expressions in lowest terms. Now, a rational expression is said to be in lowest terms when the numerator and the denominator share no common factors, other than, of course, the factors of 1 and negative 1. And when you hear the words in lowest terms, that's equivalent to saying completely simplified or completely reduced. Now, the process of simplifying rational expressions to lowest terms is as follows. To write a rational expression in lowest terms, first we will completely factor the numerator and the denominator, and then use the fundamental property of rational expressions, as discussed above, to reduce any common shared factors. Remember to put a 1 in place of each factor that's reduced. Let's now take a look at several examples. In each example, we're going to write the rational expression in lowest terms. Let's start with example 1a. 8z cubed over 36z to the 7th. First thing we want to observe in this rational expression is that the numerator and denominator are already expressed as products. There are no pluses or minuses. We can simply go about canceling common factors. 8z cubed in the top, 36z to the 7th in the bottom. Let's start with the 8 and the 36, the coefficients. What number divides or is a common factor of both 8 and 36? Well, notice 8 can be written as 4 times 2, and 36 can be written as 4 times 9. 4 is a common factor to both of those numbers. Z cubed over z to the 7th. Now notice z cubed simply means 3 z's multiplied together on the top, and z to the 7th simply means 7 z's multiplied together, and we can also cancel those 3 z's from top and bottom by using the quotient rule. Here we go. So 4 divided by 4, those are common factors. We're going to cancel and we'll be left with 1 in its place. And the z's, again, using the quotient rule, the 3 z's on the top will cancel from the 7 z's on the bottom, and by subtraction that will leave us with 4 z's on the bottom. So let's put together what we have. We have a 1 times a 2, and the z cubed was gone, so we have 1 times 2 times 1, or 2 in the numerator. And in the denominator we have 1 times 9 times z to the 4th, or just 9z to the 4th in the bottom. Looking at this, we notice there's nothing else that will cancel, and so our rational expression is now in lowest terms, 2 divided by 9z to the 4th. Let's move on to example 1b. 20x cubed over 4x squared plus 8x. Now in this example, notice the denominator is not yet factored. It's a sum of 2 terms. So the first thing we need to do is we need to factor. Alrighty, rewrite the numerator, 20x to the 3rd. And for the denominator, we have a binomial, and we factor this binomial by taking out the greatest common factor. Notice 4x divides into both the first term and the second term. So using the greatest common factor, we're going to take out 4x, and that's going to be leaving us with, inside the parentheses, x plus 2. Perfect. So now the denominator is factored, the numerator is already written as a product, and now we can go about simplifying or writing our expression in lowest terms. We look for a common factor from the numerator and the denominator. We start with the numbers or the coefficients first. Notice 20, we can go a little farther with that actually. 20 is actually 4 times 5. That will allow us to cancel a 4 from the numerator and the denominator by writing it like that. We also have x on the bottom and x plus 2. And in the numerator, let me rewrite that we had x cubed up here. We'll also observe that there's x's, 3 of them multiplied together, 1 of them down here, and so 1x will cancel with 3 x's, leaving us with 2. So let's go through that cancellation. 4 divided by 4 cancels, leaving us with 1. The 5 stays. The x, this x here, will cancel with 1 of the x's up here. There's 3 of them, so when we take away 1, that leaves us with 2. Or by the quotient rule, 3 minus 1 leaves us with x squared in the numerator. This x plus 2 term has to stay because there's no x plus 2 factor in the numerator, only in the denominator. So our final answer, when we put it together, is 1 times 5 times x squared. So that leaves us with 5x squared in the numerator. And in the denominator, the 4 and the x have canceled, leaving us with simply x plus 2. Our final answer then is that this rational expression reduces to 5x squared over x plus 2.